told you that today I was going to review with you. So I'm going to go through and work certain problems on the study guide. I'll work through as much as we have time for, but at first I'm going to skip around a little bit just to make sure that I hit something like every type. Okay. Study guides will be turned in tomorrow, so if you don't have it done, you need to have that done for class tomorrow to get your points for that. The first thing I want to talk about is number 1. I know a lot of people had questions on that one yesterday. Probably going to put something like that on your test, so I want to make sure we know what to do. So the very first thing we did in section 4 was we solved a lot of different types of equations, and this was one of them. When we have 4 terms, what strategy do we use? Grouping. Now, can you put a parenthesis after a minus sign? No. So before you group, you need to change this to plus a -4, and then you can put the first 2 in a parenthesis and the second 2. So in the first set of parentheses, what can we pull out? X squared, and that leaves us with? Okay, our goal is to make these parentheses match. So what should I take out of the second one? And that would leave you -4x divided by -4 is a positive, 12 divided by -4 is a negative. We are trying to figure out what makes this equal 0 in part A. What can I do now? If you take that out, you're left with the x squared in the first term, the -4 in the second. You could solve it from here. You could go one more step. X squared minus 4 would break into Okay. So then for part A, you set each of those equal to 0, and what do you get? Does that make sense to everybody? Part B said use the graph to find this. So if you look at the graph, go ahead and grab your graphing calculator, plug in the original for me. I think your graph looks something like this, right? So B asks where it is less than 0. Less than means the negatives. So we can see it's negative on this section of the graph. So that interval would be from -infinity to -2. And then it's negative between +2 and +4. Part C wants to know when the polynomial is greater than or equal to 0. So greater than would be the positives. If I'm looking, this graph is positive. It's above the x-axis between -2 and +2. Because of the equal to, what do I put on those?
Brackets.
And then it's a positive again after 3. Any questions on number 1? Can I skip around and kind of do a few more questions like this? Let's go to number 5. So A through D were also in this section. I may not work out all of these, but I want to talk about a few of them at least and make sure we know the strategy for each. So on A, what would you have to do to solve this one? Right. Greatest common factor is always the first step, so if you pull out that x, then you're left with x squared plus 3x minus 4. And then this is a quadratic, so we can do box method. So x squared breaks into x. Multiply -4 and add positive 3. So now you just set each of those equal to 0. And you get 0, -4, and positive 1. Did you guys do okay on that one? I want to do at least one more. On B, we need to always get these equations equal to 0 to start. So it's not going to do me any good to just factor out an x squared here. To start, we have to bring the 12 over. Once I do that, does anything come out of all of these? Do we have a greatest common factor? No. But when you see x to the 4th, x squared, and a constant, that is like a quadratic. So even though it's not a true quadratic, we can do the box method with this. Bless you. So we set up our two parentheses. X to the 4th will break into x squared and x squared. I need two numbers that multiply to a -12 and add to a -1. Okay, from here you can continue to factor. Will both of these break down some more? Yeah, just the x squared minus 4. You could break into x plus 2, x minus 2. Some of you, when I was answering questions, just went ahead and set that equal to 0, and that's fine. You don't have to necessarily factor completely here. You just have to get to your answer. One problem that I saw, though. If you add a square root, what do you have to put with it? Okay, don't forget that plus and minus. So we get plus and minus 2. Over here, the square root of -3 would be what? So we can get some i's with those. C is a lot like example number 1. If you bring everything over, then you can do grouping. D, what would you have to do? First, set it equal to 0, and then pull out your greatest common factor. So I will come back and work those if we have time later, but I'm not going to right now. Alright, next question I want to hit. Question number 3. So 3 and 4 all involve the graphing. In question 3, it's basically I just wanted to test your asymptote knowledge. So make sure you remember those rules. That might be something, I always have people tell me they don't know how to study for a math test. Well, at the very least, you could look over those rules. We wrote them all down yesterday. Make sure you know those rules. On the first one, what do I usually have you do to find the vertical asymptotes? Right, we factor first. It just makes it a little more obvious. You don't really have to factor the top on this one because we're not going to graph it, but x squared minus 9 will break into x plus 3, x minus 3. So the vertical asymptotes are x equals whatever makes the bottom 0. So that would be x equals -3 and x equals positive 3. Okay, the horizontal or oblique is based on the degree. Degree of the first, so degree of the top is 1. Degree of the bottom was 2. If the degree on top is smaller, then what kind of asymptote do we have? Horizontal y equals 0. And if you have a horizontal, can you have an oblique? No, it's one or the other. The other question I asked you was domain. The domain is very similar to your vertical asymptote. When you draw your graph, where you have vertical asymptotes is essentially where your x's don't exist. We know for the domain that your denominator can't be 0. So what I've told you, we know that x cannot be the -3 or the +3 in our domain. The bottom of a fraction can't be 0. If it is more than one value, I will let you just list it like this. If it's a single value that x can't be, then I expect interval notation. If you did write the interval notation for this one, it would be everything before -3, everything between -3 and +3, and everything bigger than 3. But I would also accept just x cannot equal those two values. Okay. Let's look at B as well. Vertical asymptote would be what?
2.
X equals 2. Okay, horizontal or oblique. What is the degree of the top?
2.
The bottom?
1.
So if the top is 1 bigger, it is oblique. On D, when you looked at that, the top was more than 1 bigger. What happens if that's the case? If it's the same, you divide leading coefficients. If the top is bigger by more than 1, like on 3D, there is no horizontal or oblique. So it is possible to not have either one. Okay, so the numerator goes underneath. You don't have to, but you can put a 0x. That kind of helps you. And the denominator goes outside. Alright, then x squared divided by x, then you multiply x times the x minus 2. So that gives us x squared minus 2x. What do we have to do at this point?
So choose.
Yeah. The x squared minus x squared cancels. 0x plus 2x is 2x. And bring down our plus 4. Then 2x divided by x. And that is all we need. We don't have to finish the long division. So it's just y equals x plus 2. Alright. Do you guys need me to talk about either C or D here? Or are we okay with this? Let's go ahead and go to number 4. It's still using all this stuff, but now I'm going to make you do the full graph. So I'd like to do a couple of those. Let's do C. On the test, I will break this into like an A, B, C, D question. So part A, I'm going to say factor the numerator and denominator. So to factor the top, what will I have to do? Box method. Can I do the shortcut? No, because of the 2. So you have to do the full box method. You have a 2x squared minus 4. Those multiply to a -8, and they need to add to a -7. So what would that be? Mhm. Okay, so 2x squared and -8x, we could take out a 2x. 1x and -4, take out the 1. 2x squared and 1x, take out x and -4. Okay, the bottom, we can do the shortcut. X squared breaks into x, multiply to -12 and add to -1. That's a 3, -4. Okay, I did this question intentionally. What happens right here? Yes. I promise you, I'm going to put one of these on your test where something cancels. When it cancels, what happens on our graph? There's a hole. You have to be able to give me the ordered pair of that hole. Okay. The x value comes from the thing that cancels. X minus 4 cancels. What makes x minus 4 equal 0? Positive 4. So that's how I got my x. To get your y, you plug 4 into the thing that's left. So if I put a 4 in, I get 8, plus 1 is 9, over 4 plus 3 is 7. So the hole is at 4, 9/7. There is one on the test that has a hole in it. Any questions about how I got that? So the second thing I would ask you to do is x and y intercepts. We talked about this yesterday, but how do we find an x-intercept? X-intercept is when y equals 0. We can use this reduced equation from here on out. If you were solving this, the first thing you would do is multiply over your denominator. And what's 0 times anything?
0.
So it's really just what makes the top 0. So if we subtract our 1 and divide by 2, get an x-intercept of -1/2. How do we find the y-intercept? And 1/3. Okay, then I'm going to ask you about your asymptotes. So vertical asymptote. You can look at your reduced one. Vertical is what makes the bottom 0, which is so x equals -3. Okay, horizontal or oblique. What's the degree of the top? Yeah, if you look at the original, it was a 2. If you look at our reduced, it's a 1. You can do either way. The bottom is a 2 in the original or a 1 here, but either way, you see it's the same degree on top and bottom. If the degree is the same, it's horizontal, and we find it by dividing the leading coefficients. So whether you're looking in the original or a reduced, both of those are 2/1, which is just a 2. I cannot stress enough, make sure you know those asymptote rules. Okay, if you're struggling, come in during advisory, I'll make a note card for you so you have something to study. But you have to know those rules on this test, otherwise you're going to lose a lot of points. So now we put all this together on our graph. And the nice thing about this, you have to plot everything you found I am going to take off on your graphs if you don't put actual points for the x and y intercepts and all of that. But you also have your calculator, so if something doesn't match up, it's a pretty big red flag that you've made a mistake. How do I plot a hole on my graph?
Also a circle.
Okay. 9/7 is a little more than 1. We hit the x-axis at -1/2 and the y at +1/3. Vertical asymptote at +3. Horizontal asymptote at 2. And then graph. I always recommend graphing the original. That way, if you messed up along the way, the graphs won't match up and you'll know that you made a mistake.
Wait, where's your 9/7?
It's a little over 1. You can put it in the calculator if you need to. Oh, yeah, it is. Thank you. Just making sure you're paying attention. Vertical, we said -3, not +3. Okay, so everybody, use your Chromebook or whatever, draw this graph. So plug in the original, make sure, remember you have to do parentheses around top and bottom. You should get something like this. Make sure, like when you draw that, you go through the actual points that you've plotted. Make sure when you draw your graphs too, that you are approaching your asymptotes. I have seen some of you who like to draw this, and that's not right, because that's not even a function. It doesn't pass the vertical line test. Okay, so make sure you're not just drawing like a horizontal and vertical line. It's not a square. It is a curve. As you go on, it's getting closer to your asymptotes. So there is one on your test like that. Any questions there? Let's do one more just for practice, because these are a lot of steps, so there's a lot of points involved on those types of questions. Yes, ma'am?
Can we do A?
Sure. Okay, so the first thing I will ask you to do is factor everything. So top and bottom. The top, how would that factor? -3 and -3. You can write it twice like this. If you want, you could also write it as x minus 3 squared. Either way is fine. Second thing, there's no holes on this one, so we don't have to worry about that. X and y intercepts. So the x-intercept, that's when y equals 0. So this whole thing is equal to 0. You would multiply over the bottom. So it's really just when the top is 0. So what do we get? 3. Y-intercept is when you plug in a 0 for all of your x's. So we get -3 squared over 0. Can you divide by 0?
No.
So what does that tell me? There is none. We never hit the y-axis. Next thing I would ask you is asymptotes. Vertical asymptote. X equals what makes the bottom 0? 0. Horizontal or oblique. So what's the degree of the top? Bottom? So you divide the leading coefficients, 1/1 is 1. Worst case scenario, guys, if you forgot how to find that horizontal, could you graph it and kind of use the graph to help you double check? Okay, so if you couldn't decide if it was 0 or 1, you could look at a graph and tell. You have that resource available. So then we draw our graph. We hit the x-axis at +3. We don't hit the y. Vertical asymptote at 0, that is the y-axis. Horizontal asymptote at 1. Then if you graph, just do the original. And make sure your graph is a curve, getting closer to your asymptotes as time goes on. Go through the points that you plotted. Oh, no, hold on. This piece is also up here. What's happening, it's kind of hard to tell without zooming in a whole lot on your graph. I told you a while back that you can cross a horizontal asymptote. What this one does is it crosses, it comes down, hits the intercept, and then it's getting closer to your asymptote from the bottom. So it looks like that.
Wait, so how is your y-intercept known?
You never touch the y-axis. When you plugged in 0, you got -9 divided by 0, which doesn't exist. So that happens when your vertical asymptote is the y-axis. Any other questions there? Alright, let's move on. We talked about the equations in section 4. We talked about the asymptotes and the graphing, that was sections 5.1 and 5.2. So the last thing was section 5.3. All of those, the rational equations and inequalities. That's the thing that's probably the most familiar to you because that's what we were working on, we reviewed on Monday. But we can do a couple of those just to make sure we remember. Let's do, on the back page, let's do F. So there's really not that many different types of problems on this test. Make sure on this one you realize there is a negative on that. Okay, where do we begin here? Let's factor, yeah, let's rewrite x squared minus 36 so we don't have to multiply by too much. So we can multiply by, or change that to x plus 6, x minus 6. We usually took a minute and wrote down what x could not equal just for checking our answer at the end. So what can x not be on this one?
6 minus 6.
Okay. So I have to multiply for the first fraction to get rid of it. We need to multiply by the x plus 6 and the x minus 6. And if you do it to one, you do it to all three. So these drop, this drops, and this drops. So we are left with a 2 plus 1 times the x plus 6 equals -1 times the x minus 6. So we distribute. If we add like terms, x plus 8 equals -x plus 6. Add subtract my 8. Divide and we get x equals -1. Is that answer okay? Yeah, we can't have positive or -6, but -1 works, so we are done. Let's see. Do we need to do another one of the equations like E, G, or H? Are you guys okay with those? Good. Okay, let's do at least one of the inequalities. Let's do J. Alright, so on this, when we had these inequalities, we can't just multiply by the denominator because of the variable. So instead, we had to do what? Right, we had to get 0 on one side and a single fraction on the other. If I subtract this 4, that is like a 4/1. We need these to be a single fraction so we get a common denominator. So we'll take it times 2x plus 1 on top and bottom. What do we need to do with this negative? So x plus -8x is -7x minus 4 over 2x plus 1 greater than 0. Okay. Once you have a single fraction and a 0, that's when we set the top and bottom equal to 0. So if I add my 4, divide by -7, we get a -4/7. And -1/2. Alright, we make our sign line. You can pick test points. A lot of you preferred to graph. However you go about that is fine. On the graph, you want to make sure you graph the piece right here when we had the single fraction with parentheses around the top and bottom. So we have -7x minus 4 divided by 2x plus 1. So we can see it starts out below the axis, so negative, then it goes above, so positive, and then it drops back down. So this one is negative, positive, negative. Which one did I ask for? Positive. Greater than 0 is positive. No equal to, so just parentheses, so be -4/7, comma, -1/2. If I had had an equal to. Would both of those get a bracket? No, which one?
This is the same.
Just the 1/2 would have, or the -1/2 would still get a parentheses because it was on the bottom. The -4, or, yeah, the -4/7 could get a bracket because it was on the top. Okay. Questions?
I'm confused on I and L.
Okay, let's look at it. So 5I is a lot like this one. We have to start by getting our 0. So subtract over your 5, that's like a 5/1. To get a common denominator, what am I going to multiply it by? On top and bottom. Okay, so if we distribute the 5, that gives us 15 plus 10x. We have this negative, so we need to distribute that. So positive 10 and negative 15 gives us a -5 minus 10x over 3 plus 2x. This is our goal. That's our ideal setup. So now we set top and bottom equal to 0. So I could add up on my 5, divide by -10, get a -1/2. And a -3/2. So then pick your method. I did the last one by graphing, so I'll pick points this time. Smaller than -3/2 would be -2. In between them, maybe a -1. Bigger, a 0. You plug in here. So if I put in a -2, I get a positive on top, negative on the bottom, so that's a negative. Put in -1, I get positive on top, positive on bottom, so positive. 0 gives me negative over positive, which is negative. Which answers did I want? Negatives. Equal to means bracket, but the -2 or -3/2 has to have parentheses because it was on the bottom. So my answer is -infinity to -3/2 union bracket -1/2 to infinity. Is that one okay? Let's look at L. So we have 5 over x plus 5 less than 3 over x plus 2. Okay, we have to get 0 on one side. To put these together, we need a common denominator. So what do we multiply the first one by? X plus 2 on top and bottom. And the second one? Okay. So if I distribute my 5, we get 5x plus 10 over x plus 2 times x plus 5 minus 3x plus 15 over x plus 2, x plus 5. Okay, if we distribute the negative, 5x minus 3x is 2x, 10 minus 15 is negative 5. Now what? Top and bottom equal to 0. So we get 5 halves, negative 2, and negative 5. So we have to look at all three numbers. You can pick test points or graph. If you graph this, you need parentheses around the top and the bottom. So we see it is negative, positive, negative, and it's kind of hard to tell, but it does go above the axis again if you zoomed in. After that 5 halves, it's just barely positive. So we have negative, positive, negative, positive. Which ones did we want? Negatives. That would be negative ND to negative 5, negative 2 to 5 halves. Any other specific questions on the study guide? Yes.
On the second page,
Uh-huh.
on B, I'm
Yes.
kind of confused about identifying the symmetries.
Oh, so your types of symmetry, basically this would be symmetric to the y-axis if I drew it perfectly, because if I fold it on the y-axis it overlaps itself. Symmetric to the x-axis wouldn't be a function, so it would be something like this. If you fold it on the x, it overlaps itself. Symmetric to the origin is basically when you have to flip over both the x and the y before it overlaps. So like this type of function. So if I'm looking at A, it's not symmetric to the x or the y. But if I fold it over both the y and the x, would it overlap itself? Yes, so that one is symmetric to the origin. If I look at B, what could you fold that one on to overlap itself? The y, so it's symmetric to the y. Sorry, I added that question in. Apparently I didn't number that one. Any other specifics? I have one for you. I gave you this one. It's not on your study guide. I'm just giving you another one since you guys didn't have any specifics from the study guide. What can x not equal? So for this fraction you would have to multiply by x minus 6. I put this one on here just because sometimes when it's just a number, I catch people that don't actually multiply this, but if you do it to one piece, you have to do it to all of them, whether or not it's a fraction. So those would cancel. What would we have to multiply by for this one? So those cancel, but nothing cancels over there. So you have 8 times the x plus 6 with 8 times the x minus 6. and -1, and then we have to start multiplying that. If you FOILed x plus 6 and x minus 6, you get x squared minus 36. And then you guys know how you would finish it from there. Multiply it all out, quadratic, set it equal to 0. Okay, so just make sure on those rational equations, even if it doesn't have a fraction in one term, you still are multiplying that term. Okay, so real quick, how do you find the vertical asymptote? Denominator equal to 0. When you write its equation, you have to put x equals. When do you have a horizontal asymptote? Okay. If the top, hey guys, I'm trying to help you. If the top is smaller, what is your horizontal? Y equals 0. If it's the same degree on top and bottom, what do you do? Divide leading coefficients. When do you get an oblique? Alright, what if it's like x to the 5th over x cubed? No horizontal or oblique. Okay. When do you get a hole in the graph? When something cancels out. Okay. Let's say it was like so the hole would be at, what's your x value? 5. How do you get the y? Like 5n. So you would get 6 over 3, so 2. If you guys need anything, come in,